Today we're looking at lesson 5.6, too big or not too big? That is the question. And our objective today is, given a linear inequality, I can use points to correctly graph and shade the full solution set in 2 out of 2 problems. So we've been looking at systems of equations in this unit, and now we're going to move on to graphing inequalities. Graphing inequalities to show their solutions. So to get started here, we're going to do a couple warm-up problems. And we're looking for at least 5 coordinate pairs xy that make this inequality true. So let's look down here. We have 2x plus 4y is less than 20. So can you think of some points that would make this true? For instance, we could try the point 1, 1. So that would be 2 times 1, we substitute in that x, plus 4 times 1, substitute in that for y. That equals 2 plus 4, which is 6. And 6 is less than 20. So yeah, that one works. Pause the video and see if you can come up with 4 more coordinate pairs that make this inequality true. Now, we'll probably get different points because there are actually infinite points available that make this true. But here are some options you may look at when you're looking for coordinate pairs that satisfy particular conditions. So one of the things I like to try is putting in a 0. Zeros are really great when we have multiplication because it makes a whole term go away. That'll make that whole x term go away. So I can put something like 0, 3, and then I would have 2 times 0 plus 4 times 3. That equals, that's 0, that just goes away. 4 times 3 is 12, and 12 is less than 20. Similarly, I could look at a 0 for the y value. So I could do something like 9, 0. Why would 9 work? Well, because 2 times 9 is 18, which I know is less than 20. So 2 times 9 plus 4 times 0. That term's going to go away. 2 times 9 is 18. That's less than 20. Another option you could think about, this one's a little bit even bigger stretch, is we could do negative numbers. We know that negative numbers are always less than 20, so we could do something like -3, -5. So 2 times -3 plus 4 times -5, that's going to be 2 times -3 is -6, 4 times -5 is -20. So that equals -26, and that is, of course, less than 20 because it's a negative number. And one last one, maybe just like a simple one like 3, 2. 2 times 3 plus 4 times 2, that'll be 6 plus 8, which is 14. That is less than 20. So that's how we come up with points that satisfy particular conditions. We just basically choose any random number we want, and we can plug it in and see if we can come up with another number that makes this true. Okay, another warm-up question. Write this statement as an inequality. It will cost at least $50 to buy 2 different video games. Okay, so to buy 2 different video games, that makes it sound like we have 2 variables here. We're going to buy video game 1 and video game 2. I might use variables v sub 1 and v sub 2. Remember we had those subscripts? We introduced those a few units ago. That just means these are 2 different variables, but they're kind of related. So this would be like video game 1, and this would be like video game 2. And the cost of them would be, well, those added together, right? This is the cost of 1, that's the cost of 2. We add them together, we get the total cost. So let's see, it will cost at least $50. So we're going to compare this total cost to $50. And it says at least 50. So this least word, least, refers to the 50. So if you remember our alligator eats the bigger side. Least tells us that's the smaller side. Least means smallest. So that's pointing at the 50 because it says least 50, at least 50. And then we have an equal sign because that would include the $50. That would be an option to be the cost of the two games. It'll cost at least $50. So $50 or greater. That's another way we could think of this. $50 or more. So it equals $50 or it's more than $50. So there's our equal, there's our more. So this altogether is our inequality that represents this statement. Let's try another one. Write this statement as an inequality. We expect at most, all right, we've got a different phrase here now, at most 60 children and adults to attend the family reunion. Well, we have a couple of unknowns. We don't know how many children and we don't know how many adults. So those sound like our unknowns. Maybe we use C for children and A for adults. And it looks like we're going to compare that to 60, so I'll have a 60 over here. And now we have to decide which direction this inequality goes. So we have at most 60. So the most is referring to 60. Most means biggest. Alligator eats the big one, so alligator is going to try to eat the 60. At most 60. Another way we could think of this, or rephrase it, we could think of it as 60 or fewer. So just like in that last problem we did, that tells us we need an equal sign because it could equal 60, and then the total amount will be fewer than 60 or equal to it. So that's our inequality for this statement. One more of these. Write this statement as an inequality. The total cost for a morning and afternoon snack should not exceed $10. Well, our two variables again, we might have an M for morning and then A for afternoon. Oh, can't see that at all. A for afternoon. And if we add those together, we'll get the total cost, M plus A. And it should not exceed $10. So we're comparing it to 10. And this is interesting, though. We have a not in here. We're going to compare it to not $10. Or not exceed $10, rather. So one way to think of exceed is this is be bigger than, right? That's what exceed means. It means to be bigger than something else. So it should not be bigger than $10. Well, if the total cost is bigger than $10, that means the alligator would eat the total cost, which is over here. But it's not bigger than $10, so alligator is going to eat the $10 instead. Not bigger than 10, that means 10 is bigger. And it could also equal 10, because 10 is not bigger than 10. 10 is equal to 10. So 10 doesn't exceed 10. So this entire cost could be $10 or less. So that's another way we could rephrase this to make it make more sense to our brain. Be $10 or less. And you can see now the total cost is equal to $10 or less than $10. So if we look at those last three, how did we know that they were inequality problems? What words in those problems tipped us off that we're going to be looking at inequalities instead of equalities? Well, let's see, our first one, we had it'll cost at least. At least sounds like a less than. Or it sounds like the $50 is going to be less than something. In our second problem, we had at most. At least, at most. And then in our third problem, we had should not exceed. In particular, exceed tells us this is going to be an inequality problem because it tells us something is bigger than something else. So what other words or phrases might you see in inequality problems? Can you come up with some? We could see more than or greater than, which is exactly how we say that symbol. Or we could have less than, which is this symbol. We might see fewer than. That's for countable things. We might see something like up to 15 minutes. So all of these are options, and there are many, many more that you might see in problems that tell us that we're comparing one quantity to another quantity, and we expect one to be larger than the other. All right, so good job coming up with all of those. We are going to move on now back to our story on Carlos and Clarita and their pet sitting business they've been working on. So after a few weeks of running their business, Carlos and Clarita realized it would be wise to separate the cats from the dogs. Now, can you imagine why that might be? Why we might want to separate cats from dogs? Let's take a look at why. So there was maybe this unfortunate event. And we also might want to prevent a repeat of the unfortunate cat and dog tango incident. So it might be a good idea to separate the cats and dogs. And we can do that by buying cat pens and dog runs that will keep the cats and dogs separated. So Carlos and Clarita have decided they can spend at most, oh, there's that term, at most, $1,280 to purchase cat pens and dog runs. So this sounds like an inequality. Cat pens cost $32 and dog runs cost $80. So let's see if we can come up with 5 combinations of cat pens and dog runs that would cost less than $1,280. So Carlos and Clarita, if they don't want to spend that entire budget, let's find some combinations they could do. Well, let's see. How about 0 and 5? Once again, I love using zeros because it makes this multiplication problem so much easier. So that would just be 32 times 0 for each cat pen, and $80 for each of 5 dog runs, so 80 times 5. 32 times 0 is 0, 80 times 5, that's 400, and that is indeed less than 1280. So this point works. How about, I'm just picking random numbers here and checking them, 11 and 8. Let's see if 11 and 8 work. I'm going to need my calculator for this one. So 32 times 11 cat pens and 80 times 8 dog runs. 32 times 11 plus 80 times 8, that equals 992. That is less than 1280. And again, I'm just going to pick some random numbers and see if they work. How about, let's do 17 and 15. Let's see if that works. 32 times 17 plus 80 times 15. So 32 times 17 plus 80 times 15. Oh, that's 1744. That's too big. That didn't work. That's not less than 1280. So this is a no. That one does not work. But that's okay. We can try whatever numbers we want, any numbers that help us. So we just keep trying more numbers. We know that these numbers are too big, so maybe we'll go smaller than that now. How about 7 and 4? I bet those will work. 32 times 7 plus 80 times 4. Do that in my calculator. I get 544. That is indeed less than 1280. So that one works. We're looking for 2 more points. See if you can pause the video and come up with 2 more points that fill these criteria. Now we'll probably get different points, but that's okay. Hopefully you got a couple. Let's try 9 and 5. Let's see if that works. 32 times 9 plus 80 times 5. Put that in my calculator. That's 688. Yep, that is less than 1280. Cool. And then let's try one more. Let's try like 13 and 12. That might be too big, but we'll see. We'll see. 32 times 13 plus 80 times 12. That's, oh yeah, that is too big. That's 1376. That one didn't work. Nope. So we need to go a little bit smaller there. Maybe let's do 13 and 8. Let's try that. 32 times 13 plus 80 times 8. Ah, yep. 1056 is definitely less than 1280. So there we go. We have 1, 2, 3, 4, 5, 6. Oh wait, this one was a no. That's a no. So we have 1, 2, 3, 4, 5 points. That's what we were looking for. 5 combinations that cost less than $1,280. And our next instruction here is to plot them on the next page. So I'm going to scroll down to this next graph and plot them. Okay, I had to write them down on a piece of paper so that I could see them on the slide. We had 0, 5. So that was right here. 11, 8. So over to 11 up to 8 here. 7, 4. So 7, 4 is down here. 9, 5. That one's right there. And 13, 8. 1, 2, 3, and 8 is here. So that's some samples of combinations of cat pens on our x-axis and dog runs on our y-axis that are under their budget for this business. Now, as you might be able to tell from this color key, we're going to do some other comparisons. Now we're going to look at some combinations that are too big. Let's find 5 combinations that would cost more than $1,280. See if you can pause the video and come up with at least 3 on your own. We'll do 5 together, but see if you can come up with at least 3. Okay, so we're going to want larger numbers this time. We tried some already that didn't work. Maybe something around 1715. I think we tried that one before. So 32 times 17 plus 80 times 15. Let's see what that equals. 1744. Yes, so that is definitely bigger than 1280, which is what we're looking for now. So that one works. How about, well, if 1715 works, probably anything bigger than that works, right? So how about 23. 32 times 20 plus 80 times 23. That's going to be 2,480. Definitely bigger than 1,280. Let's see if we can go smaller than this and still get above 1,280. Let's try, maybe let's try 12 and 14. Let's see if that works. 32 times 12 plus 80 times 14. That equals 1504. Yep, that is bigger. Okay, how about 930? 32 times 9 plus 80 times 30. So lots more dog runs in this one. 2,688. Yeah, that is bigger than 1280. And we need one more. Maybe we'll just pick like 20 and 20. Nice symmetrical coordinate there. 32 times 20 plus 80 times 20. That's going to be 2,240. That is again greater than 1280. So now we're going to go back to that same graph and we're going to plot these, but now we're going to put them in a different color. We're going to do these ones in blue. Okay, so let me get my blue pen. Okay, so our points were 17, 15, which is right up here. 20, 23, which is up here. 12, 14. It's right there. 9, 30, way up here. And 2020 was our last one, which is right here. So we've got some blue dots that are too big for their budget. Okay, so last set, we're going to go for ones that are just right. Now we're looking for 5 combinations that cost exactly $1,280. So let's see if we can figure that out. Well, I think a really great way to try these is with our zeros trick again. Let's try putting in a 0 for x and see if we can figure out what our y needs to be. So if we have 32 times 0 plus 80 times y, we want that to equal 1,280. Well, this term goes away. We just need to divide by 80 and see what we get. I'll put that in my calculator. I get 16, y equals 16. So yeah, that one worked out. We do need whole numbers for this because you can't buy a 0.5 dog run or 6/10 of a cat pen. So we need whole numbers, but 0, 16 works. Let's try 0 in our y coordinate. So now it'll be 32 times x plus 80 times 0 equals 1,280. So basically we just need to divide by 32 now. Let's see what we get. 1,280 divided by 32 is 40. So there are 2 points. Our zeros are points. And now we need to just think of some other points, maybe try to come up with some. And one of the ways I like to do this is to figure out how to get this last digit, right? So 0 times anything is going to be 0. This is always going to end in 0. But 2, how do I get that to end in 0? The only thing I can multiply 2 by to get it to end in 0 is 5 or 0. So let's try something that ends in 5 or 0 for that one. Let's try 15 maybe. 15 for x and see what we need to get for y. So 32 times 15 plus 80 times y. 32 times 15 is 480. We subtract that from both sides. This is an 8, 80y equals 800. Well, we can do that math in our head, right? Divide both sides by 80, we get y equals 10 on this one. Y equals 10. So 1510 is a point that's exactly right. Let's try 10. Maybe we can try 10 for the cat pens. Let's see what we need. Well, 32 times 10 is going to be 320. And then some number of dog runs equals 1,280. We subtract 320 from both sides. We get 80y equals 960. Then we divide both sides by 80. That looks like 12. Let me make sure I did that math right. 960 divided by 80 is 12, yeah. So 10, 12 is one of these points. And we just need one more. So we tried 0 for the cat pens, 40, 15, 10. We know it needs to end with 5 or 0. Maybe we'll just try 5. Let's try 5. So 32 times 5 plus 80y equals 1280. 32 times 5 is 160. We will subtract that from both sides. We get 80y equals 1120. We divide both sides by 80, and we get 14. Y equals 14. Yay! So those are all integers. Those all work out. Let's go back and plot these. All right, we're going to plot these ones in green. So we had 0, 16. That's right here. We had 40, 0, which is right here. We had 15, 10. That's here. We had 10, 12. And we have 5, 14, which is right here. So let's look at this graph for a second, just kind of stare at it, and see if you can notice any patterns with the colors. Do you see any specific way that the blue dots are arranged or where they fall versus the green dots versus the black dots? Now, one thing you may have noticed is that these green dots seem to follow a straight line. So I could kind of draw a line like this. I'm just drawing this freehand, so it probably won't match up exactly, but we'll get there. So these green dots do follow exactly a straight line. And once we've drawn that straight line, what else do you notice about the blue dots and the black dots? You may have seen that the blue dots all fall on the same side, on the top side of this line, whereas the black dots fall on the bottom side of this line. So everything that's too big for their budget is above this line. Everything that's too small for their budget, or below their budget at least, is below the line. And then everything that meets their budget exactly is right on this line. So this is what the graph would look like if we had several more dots plotted. We'd have a bunch of blue ones above, a bunch of black ones below, and then all the ones on the green right on the line. And we want to write an equation for the line that separates the graph into two half planes. Now, we haven't talked about what planes are, but you can think of it basically as a sheet of paper. It's something that's flat and only has two dimensions. A coordinate plane, we call this a coordinate plane. And this line right here will divide the coordinate plane in two pieces, one below it and one above it. So we want to write an equation for this line. Now, if we think about what we were doing before with these numbers, we were saying 32x, right, for cat pens, plus 80y for dog runs was our total cost, which was $12.80. And we were just solving that over and over and over with a bunch of different points. And this is, in fact, a linear equation. It makes a line, and it actually makes that line in particular right there. So what does the slope of this line represent? We don't even actually know what the slope is. It's some number, but we can't tell it from this form, right? We don't have slope-intercept form. We don't know what the slope is. So this is kind of like, I don't know what that means yet. Let's see if we can figure it out though. So 32x plus 80y equals 1280, the one we just came up with, is called standard form. This is a form of a linear equation that's like ax plus by equals c, where a, b, and c are all integers. To find the slope, we need to change it to slope-intercept form. So if we want to get the number of the slope, we need it in this form, right? And then we know that The slope is m. So the way we can do that, the way we can change from this form into this form is to solve for y. Let's try doing that. We have 32x plus 80y equals 1280. If we solve for y, we're going to circle our variable of interest. We shall highlight our other terms so we know what we need to get rid of. And then we just proceed to get rid of the furthest away terms. So 32x is furthest away. We'll get rid of that one first. I'm going to subtract that entire term to get rid of it. And because I want this in the order of mx plus b, I'm actually going to put this x term first. So I'm just going to say negative 32x first. Add that to 1280. On the left side, we are left with 80y. To get y by itself, I now divide both sides by 80. And we get negative 32 over 80x plus 1280 divided by 80. I think that comes out evenly. Let me see. 16. Oh yeah, that makes sense, right? Isn't that where we crossed the y-axis before? If we went way back to our graph, let's see. You can see right there. Yeah, we cross at 16. That's our y-intercept. So it makes sense. That became our b value. And then we're not going to spend a lot of time showing how to reduce fractions, but both of these are divisible by 16. So we are going to reduce that fraction as negative 2 over 5x plus 16. There's our y-intercept, or our slope-intercept form. Our slope is negative 2/5. Our y-intercept is 16. So our slope is negative 2/5. Let's see what that means. We go down 2 over 5, down 2 over 5. So every time we give up two, these are dog pens, 2 fewer dog pens, or dog runs rather, sorry, we get 5 more cat pens. So if we reduce the number of dogs we're boarding, we can increase the number of cats we're boarding. Decrease the number of dogs by 2, increase the number of cats by 5. And every time we decrease by 2 dogs, we can increase by 5 cats. So that's what the slope means in terms of this context. All right, so now they're asking us to shade the section of the graph that represents all possible combinations of dog pens and cat runs that fit within their budget. So was that any of these? It wasn't. These were too big. These ones are not too big. So anything on the line worked, and then anything below the line worked as well. So we'd shade everything in this region. And I'm not going to fill it in entirely, but we would color that. Everything below the line is what fits within their budget. And over here it's asking what inequality represents the shaded area. If we use this equation, our slope-intercept form, we basically just replace that equal sign with an inequality. And we say y is our value. Y is what's shaded, that is below the line. So we say y is below the line, y is less than the line. This is the line, y is less than it. And it can also be on the line, so we put that equal sign there. And this is our inequality that represents this context. The number of dog pens has to be less than or equal to negative 2/5 times the number of cat pens plus 16. Those are the possible combinations we could do with these constraints. And just a quick question at the end here, how would this graph change if we didn't want to include the combinations that equal exactly 1280? If we didn't want to include this line? Well, we'd make that a dotted line, right? Dotted line tells us that it is not including those points. And when we wrote the equation, negative 2/5 x plus 16, we'd still have it be less than, but now we wouldn't have that equal sign underneath. So that finishes up today's objective. Given a linear inequality, I can use points to correctly graph and shade the full solution set in 2 out of 2 problems.